So if you're following along, what I'm actually going to do is I'm going to start a new project. I'm going to do another command line project. So let's see, this is week 4. Okay. So we're going to talk about arrays, strings, dates, exceptions, and error handling. Okay. So can anybody just give me the layman's terms explanation of what an array is?
Collection of objects.
It's a group of objects, a collection of objects, a list of objects. So,
Variables, things like that.
right. So arrays, essentially, if you think about it from a mechanical standpoint, you're basically taking variables of the same type and you're putting them together in a group. From the lower level of the system, it actually is putting them in a sequential order in memory so that they're easy to access. And typically arrays are finite, they're fixed. So when you declare an array, you establish that array and you're basically telling the computer, I need you to find contiguous memory that is X size of an integer, and I need you to find 10 of those. 10 contiguous spots of memory that's the size of an integer. So it's an array of integers. So when you say int square brackets number array, that's telling the compiler, telling the computer, go find me some space in memory. Actually reserve that space for me. That space cannot grow, it cannot shrink. It's fixed and set the way it is. So, again, that declaration is simply int, open bracket, close bracket, number array. That's the array. That's the array variable. There's nothing inside of it. It's just this carved out section of memory. To actually initialize it to a particular size, we'll say number array equals new int, and then open bracket, number 10, close bracket, semicolon. So we now have an array with 10 positions in it. Just like in Java, the arrays are 0 based, so when you're accessing each position in the array, it's 0 through 9. The only thing that can be stored in this array is integers. You can't store strings, you can't store dates, you can't store floats or anything else. Just ints. Now, depending on what you're doing, that can be kind of tedious because then you got to populate this thing. So let's say we're creating an array, 0 through 9. We want to fill it 1 to 10. So then you would have to say number array 0 equals 1. I'm just going to copy and paste. Number array 1 equals 2. 2 equals 3. 3 equals 4. Or 3 equals 4. 4 equals 5. And 5 equals 6. And you get the picture. So we've now populated this array. So what can we do with this? We can output it to the screen, we can wrap a loop around it, we can do a lot of different things. This is not the only way of initializing an array of values. We could also do a shorthand. We can do int, open bracket, close bracket. I'll just call this array 2. And then I can say equals new int, open bracket, close bracket, curly bracket, and then I can just go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Close curly bracket, semicolon. This notation is equivalent to what we did above. We did it in one line instead of 10 plus 2, 12. So either way, this will give you an array with 10 positions, initialized with numbers 1 through 10. Array 2, we can still access it just the same way. This will give us the number 2. Is this the second? Number 1 is technically referencing the second position in the array. You can actually do an even shorter notation. Equals new, open bracket, close bracket, curly bracket, 2, 3, 4, 5, 6, semicolon. And what's now happening in this case is that the compiler is inferring the type of the array from its contents. So since we only put integers in the array, it's inferring its actual type by the content. It's saying there's only integers in here, therefore this is an integer or an array of integers. If I were to come back here and start putting the letter F behind them, if you remember, this designates these as floats. The compiler is going to yell at us and say, you're attempting to assign an array of floats to a variable that's an array of integers, because the contents of it is now floats. If we back up a couple of these floats, we'll still get a compile time error. And if we add in here maybe a string, it'll actually tell you that it cannot determine the type of an array that you're trying to declare. So it only picks up on simplistic collection types. So if you're using all the same data type, it'll be able to infer that. Now it doesn't only work with numbers. You could create an array, and I'm going to use the var keyword, which is an implicit association. So what it does is that if we say var array 3, it's going to look at what's being assigned or stored inside of the variable named array 3, and it's going to make it that data type. If you've ever done JavaScript, you know there's the var declaration for all your variables. It's not the same thing. It will strongly type that variable to a particular type, but it's implied by the assignment. So whatever's on the right side of the equal sign is what it deduces this variable data type to be. So let's do this. Object O equals array 3. So right now, if I mouse over array 3, it just says var array 3. It doesn't know what the assignment is because we have the red squiggle. If I get rid of the string here, takes away the squiggle, F6, I can compile successfully. If I mouse over array 3, it now says array 3 is actually an array of floats. If I whack all the numbers, put some strings in there, mouse over array 3 again, it's now an array of strings. If
I get rid of the strings, and I say datetime.now, comma datetime.today, new datetime 2013-09-20, new datetime 1980-05-24. Array 3 is now an array of date times. We could also make, if we wanted to be explicit in mix and match, I don't know why you would, but let's say you did. You could say new object, string. If you remember from the first week, all objects within the .NET framework inherit from the base type object. It's an implicit inheritance. Everything derives from object. So if you ever end up where you need a collection of hodgepodge data types, you can always store it in an array of objects. Now, you better hope that you know how to cast them back if you actually need the data. So you have to remember the sequence that they're in there, but then you can go back and say string, and this is position 0, 1, 2, 3, 4 as string. So since we're on the topic here, what are other ways you can cast variables? String str2 equals string array 3, 4. That's another way to cast. That's probably the way you saw it most often in Java when you were doing castings, is you would put the data type in front of the variable in parentheses. Using the as string works great for any class that you're doing a cast. And the reason why it works better than the parentheses is that when you do it in parentheses, it's an explicit cast. You're basically telling the compiler, this is this type. This is a string. If for some reason it's not a string, you'll get a runtime exception. You'll get an error. If you use the as data type, you can only use it for classes. You can only take an object and cast it as some other class. A string is a class. Your int, your floats, your bools, your bytes, all of those are primitives. They're not considered classes. They're actually structures. So you cannot have them equal null. But with anything that's a class, this will evaluate it, attempt to cast it to that type, and if it fails, it'll return null. So you can use it as a safe cast, and you don't run the risk of getting a runtime error. You simply have to check for null. And then the third option, which I think we talked about before, is the convert to string. So doing that casting that way as well. The last two will throw an exception if it's not possible. Casting to string, you can cast anything to string because it's part of the, every object has a toString method. So you'll get something. May not get what you want, but you'll get something. But this one, for anything that's a class, is a definite guaranteed way to do it. Okay. Now, there's other types of arrays or collections. They all exist under system.collections. So we have array lists, bit arrays. There's a lot of base classes if you want to build your own unique collection types. There are dictionaries, hash tables, lots of interfaces, which we'll talk about later. There's queues and sorted lists and stacks. So you have a lot of options there, as well as generics. Now, generics, did you guys cover generics in Java? Okay, seeing a lot of lost faces. Okay. So what a generic is, in its most basic sense, is the ability for you to strongly type something, but doing it dynamically. Right. So in Java, actually, you didn't even have these really in Java. Do you know what the array list in Java was? You do array list, and then you do the angle brackets and put the type in the middle. Did you ever use that? Okay, that is a generic. So what you're doing is you're saying create an array list, create this dynamically growing list, but type it, strongly type it to whatever data type I put in the angle brackets. So it's like building an array, but you're giving it a specific type and you're doing it kind of at compile time, at runtime. You're telling it what it is. So if you think back to when we did this array here of objects, we could put any kind of objects inside of it. We could put strings, we could put date times, we could put numbers in here if we wanted to. We can add a number here. So 1, comma, 2.5, comma, I could put a Boolean in here if I wanted to. So I have this hodgepodge of data in this object array. In .NET, under the system.collections namespace, there's this array list. So I'm going to say var array list equals new array list. So if I go array list dot add, what it takes in is an object. So I can put anything in there. It's not unique, it's not strongly typed. So I could put in a number, then my next line, I could put in a string, next line, I could put in a date time, and then I end up with this dynamically growing list of objects. And again, unless I keep track of what's at what position in the array list, I have no guarantee of being able to bring it back, because when I go ArrayList.get, or I'm sorry, using the indexer, if I say 0, if you look closely at the IntelliSense, it basically tells you that when you call this array list with an indexer, you're going to get back an object. You're not going to get back a string. You're not going to get back an integer. You're not going to get back date time. You're just going to get back an object. And then you as the developer are responsible for knowing what that actually is. So how do you overcome running the risk of getting data in there that you don't want, and guaranteeing that what's in there is a string, or guaranteeing that it's a date time, or guaranteeing that it's your class? You use a generic. So list, which lives under the system.collections.generic namespace, list, we can say make this a list of booleans. It's not very useful, but go with it. So we'll say it's a bool list equals new list of booleans. So then when we say boollist.add, the only thing it allows us to add is a boolean. We say boollist.add 1, it's going to yell at us and say that the value int cannot be cast to bool. Doesn't fit, doesn't work. It's not the same data type. On the other side, when we say boollist 0, we know that we're getting a boolean back. We're not getting an object that we have to guess and hope and try to cast. Comes back every time, perfectly. So what good are these lists, this list class? What good is it? Well, if you're ever building an application where you're adding an unknown number of items into a collection, you're trying to build a list, and you're leaving it up to the user to define the number of items they want to put in the list, I would recommend using the list class. So what's a real world situation? Shopping cart. You're building an e-commerce site. So you have all these products that are listed out there, and you're telling the person, go out and find whatever you want to buy and add it to the cart. So if you use an array, you could say, all right, I'll declare an array of 20 items. I've done some analysis. On average, nobody buys more than 20 items in a particular transaction. If I want to be safe, I'll do 50. No big deal. It's not a lot. It's a little bit of memory. No big deal. Well, what happens to the one guy or girl that wants to go out and buy 51 items or 60 items? I'm doing my Christmas shopping. I'm just getting it all done. You run that risk of hitting that barrier. What does your program do? It chokes and dies because it didn't know how to deal with that list. Using a list of type product, so if we were to go in here, add class product, let's say this has string product ID, string name, float price, string category. So that's our product class. Shorthand for building those properties is prop, tab. Gives you that blueprint. Type in the data type, type in the name, hit enter. One and done. So I now have my product class, and I want to create a shopping cart that can hold all those products. So I come back here. I can say list product shopping cart equals new list of products. So I can say shopping cart add. Maybe I'll come up here and go product P1 equals new product. I don't think I've shown this to you yet either. Shorthand for initializing an object. So I created this class product. It has, what, 4 or 5 properties? 4 properties. Probably in Java, what would you do? You'd say new product, and then you go P1 dot category equals toy. P1 dot name equals bike. P1 dot price equals 120. P1 dot product ID is child bike. Right? That's how you'd initialize it. In C#, we can use curly brackets. We can drop the P1 dot. And just list, comma separated, all the properties for that instance of that object. Initializing it right there in declaration. So no need to create it and then initialize the properties. You can do it all in one swoop. So now I can come down here to shopping cart and say add P1. If I want to do it 5 times, I can do it 5 times. If I want to do it 25 times, I can do it 25 times. And that list will grow dynamically as I continue to add items.
So you don't add whole list each time or one item?
You want to add a list of items?
So it's gonna add when you add the one.
Yeah, every line there is going to add one item to the list.
one item, not all items at the same time. Not the list, only single items.
Right. It's going to take the one item, P1, and add it to the list that is the shopping cart.
But P1 is the list.
No, it's just one item.
Which of them is P1, right?
This entire chunk is P1.
Yeah, that's what I'm saying.
Yeah, it's not a list. It's one
Okay, one
product.
item with the attributes.
These are the properties, yes. Yes. So these are the properties of P1.
So like one row, let's say.
Yes. So I can do P1.name, console.writeLine. And that's how I would spit out the name of that product. Am I going too fast? Okay.
Can you explain this again? I think I understand it, but I just want to hear. So it comes from the system collection, I think it's like a data, system.collection, right? That's
Yeah.
where it comes from.
Yes. Yeah. So it lives underneath that namespace. And what it is, and the reason they use the term generic is that it is built in such a way that the implementation is generic. Okay? So it is built to act as a collection, and it gets, let's see, it's built to act as a collection, but it doesn't matter what type of collection it is. It's just an arbitrary collection. It's basically, under the hood, it treats everything like an array of objects, if you want to think of it that way. But then when you give it the data type, bool or product, it suddenly casts itself and it constrains itself and says, okay, I'm only going to allow items of that type to be inserted and removed, added and get from this collection. It won't accept any other types. This particular instance, so this variable, shopping cart, only allows you to put products into its list. But bool list only allows booleans to go into its list. You're not locking the list type down, you're locking down that variable to only allow those types.
Makes sense.
Okay. Okay. There's a lot of other collections within the framework, stacks and queues. Do you guys know what stacks and queues are? Okay. So stack is the ideas of a stack is first in, what is it? First in, last out. Queues are first in, first out. Okay? So if you have a stack, think of it like a cylinder. First item that goes in goes at the bottom of the stack. Add 2, 3, 4. And then you pop items off the stack, so the one that comes off the top was the last item to be inserted. Okay, so if I add the number 1 in first, then 2, then 3, then 4, as I add them in, they're put in from left to right. Then when I take them out, I start from the right side and pull them out. A queue is the other way. So when these are in, they're inserted 1, 2, 3, 4. When they're out, they come out 4, 3, 2, 1. Q is in 1, 2, 3, 4, and it's out 1, 2, 3, 4. So those structures exist. You have generic versions, and you have just a standard version of it that takes just objects. It treats everything as an object. Then you can use the generic implementation, which is specific. It sounds very backwards, but it's true. So if you use the ones under the generic namespace, you can constrain them to a particular type. If you just use system.collections.stack, it treats everything again as an object. The reason for having both is that in version 1 and 1.1 of the .NET framework, when it was released in 2000, this idea of a generic didn't exist. So all collections treated everything as objects except for arrays. Then in .NET 2, they came up with the concept of a generic and allowed you to strongly type your collections. So most people now only use the generics because you get better control. The ones that treat everything as objects are still there, and they still have benefit in certain scenarios, and they're there for backwards compatibility. But I would advise not using them unless you have a specific case for using the ones that treat everything as an object. If you can, use a strongly typed one. Use the ones underneath the generics namespace. Okay. Strings. Strings are not anything new. Shouldn't be, hopefully. Strings are just sequential characters treated as one unit. Okay. When I say it's a sequence of characters treated as a unit, you can take any string and convert it into an array of characters. You can even take the string itself and just peel them off. Strings are considered immutable, which means that when you declare name, we'll call it F name and L name, if I decide to say F name equals Kevin plus Gantos. Here, let me do this one. String full name. What happens is that it's not going to attempt to combine the two existing strings and make them one string. It's actually going to construct a brand new string from it. So let me give you maybe a better example here. If I say F name plus L name, full name. If I were then to say F name equals Steve, and then I do console.write full name, the full name is not going to print out Steve Gantos. It is not referencing F name and L name. It's actually taking those values and it's cutting them, or it's copying them and concatenating them together as a single array of characters. It has no reference of the F name and L name variable. So if I make changes to a string, I'm actually getting a new string out of If I were to do full name dot remove, and I say start at 0 and go in 5 characters, 0 being the first position in the string, 5 being up to the 5th position. And I call this function. The full name variable is not, the value inside of it is not affected. So if I were to do console.write, or write line, let me put a I'm going to run that. I don't lose characters. The remove does not actually take characters out of the array. What remove does is it declares a brand new array of characters, and if you look at the remove signature, it actually returns you a new string. So I say string new name, and I write out new name. New name is the string that's missing the 5 front characters. Full name is still full name. So that's why they're immutable. You can't manipulate a string in memory, you can simply create a new one. So when you have the need to build a string over time, where you're doing string plus a new value equals, so if you say full name equals full name plus A, you're actually making new strings every time. You're not simply appending the letter A to full name. You're actually making a whole new string and putting it in full name. And then you do it again and again and again. So why is this significant? Why am I even bothering to tell you this? It is very memory intensive to do something like this. Because every old string lives in memory for a period of time, and every new string obviously has to go into memory. So as you're going through something like this in a loop, you can chew up a whole lot of your system memory by just connecting strings together. Now, is it bad to do 5? No. Is it bad to do 50? Probably not. You start to do 1,000 or 2,000 or 10,000, and you may notice a little bit of a memory creep in your program. So as you're doing things in your code, as you go through doing that, be cognizant of these things. They sound like little, no big deal type situations, but they can be very significant. A program I was writing about a year ago, I ran into this very same thing where when I had written it, I was aware of this whole thing with strings, but I didn't think that it was going to be that big of a deal. I was dealing with small amounts of data. Well, when I rolled it out into the real world and people started using it, all of a sudden what I thought was a loop that may iterate 5 or 10 times, because they were loading up little chunks of, flat files. They were loading up comma-separated documents. Suddenly, we're processing files that have 10,000 plus rows. And that little program that ran in 2 megs of memory suddenly started taking up 2 and 3 gigs when it was running at 2 in the morning. Because it was just doing this 10,000 plus times. So those are things to always keep in the back of your mind as you're doing this development, whether it's C# or Java or anything, is just being aware of your environment and thinking about what are worst case scenarios. Yeah.
So what was the fix for that? How did you fix it?
What's the fix? Thank you for asking. If you look under system.txt, there is a class called a string builder. The string builder has an append method. And what the string builder does is at a very low level within the system actually does true string concatenation. So you can put in here full name, and then you can append A, and you can do this forever. And the amount of memory that's taken up is relative to the characters you're appending to the string. You're not creating new strings constantly, you're simply appending those characters to the existing string. That's not something that you can accomplish at this level in C#, and the reason is that you're running within that virtual machine that we talked about in the first week. That virtual machine was written by very smart people that deal with a lot of assembly and C programming. That system is dealing with it at the assembly level. It's dealing with it at the memory address level. They're actually allocating blocks of memory like you would an array and adding characters into that array one position at a time, or X positions depending on the number of characters you're appending. You know, I can add full strings in here. That's not how you spell it. That's right. Whatever it may be. You can add these strings in. Because it's doing it at that level, you don't run into the bloat situation. So the string builder is probably your best friend when it comes to doing large iterations of text. Even if you're doing small ones, you're not going to hurt yourself by using this class. But there's also times where you just want to this plus this and be done with it. And there's nothing wrong with that either. If you're doing small strings that you're concatenating, but you get into large strings, heavy strings, strings that you don't expect, you may want to reevaluate your methods. Okay? So, what other kind of fun stuff can you do with strings? Every string has its own series of methods. You can clone strings. You can search within a string to find any instance of another string. So, you know, like when you open up a text file and you do a find and you try to find a particular string in there, you can do that. Contains returns you a Boolean value saying yes, it's in there. Further down, there's index of, which will actually return you the character position within the string. So if you want to pluck out a particular word or you want to omit certain segments of text, index of does that for you. You can do an ends with. I use this a lot when I'm parsing HTML and I'm trying to find those little stupid BR tags that are at the end of the line and I want to pluck them and take them off. You can do ends with. There's also a starts with, equals, obviously. This is actually kind of a fun method. It's called joins, and it comes off the string class itself. So let's say you have an array of strings, and you're wanting to spit them out onto the screen. Maybe you have, you're dealing with all those products, you want to spit out on the screen just a nice little list of here's all the products that you selected. Join will take an array of strings and a separator, and it will build for you a string that is value, maybe if you use the comma separator, value, comma, value, comma, value, comma, value, comma, all in one line with one call. You don't have to build a loop, you don't have to use a string builder. Just call string.join, say comma, here's the array of names, or array of values. And it'll build that string for you, one line.
Can you explain that one more time?
Sure. Yeah, let me give you a concrete example. So let's say we have a string array. Okay, so I got this string of names. For loops, everybody know what for loops are? So if I wanted to have a string of all names, that's going to be what I'm going to store it in. I then build a for loop, and I would loop until myArray.length. So then I say all names equals all names plus myArray I plus comma. Right? I probably need to initialize this to an empty string. So what would that do? It'll go through and it'll loop through everything, appending it one at a time. If I do a console.write all names, it'll spit out something like this. You always end up with that freaking comma at the end. That's the thing that always pisses me off. How do you deal with that? Then you got to go in, and you go all names dot remove all names dot length minus 1 comma 1. And then since they're mutable, you got to go all names equals all of that, and then you run it. Oop. Names. And now I got rid of the comma. So it now took me 1, 2, 3, 4, 5, 6, 7, 6 or 7 lines of code to take that array of strings, put them together into a comma-separated list. Not a terrible thing, but it's a pain, especially if you're trying to wrap that inside of something else. Then you have to build a function to go in and concatenate the strings together, and then you have to call that inside of maybe something else that you're trying to nest, and it just becomes this big ordeal. I can do the exact same thing, saying string.join, comma, myArray. It's a lot easier than writing a for loop. Now sometimes you run into the inverse. You have something that's separated by a character and you want to split it. String.split. All names, string variable, split. So this will take the string with commas and split them on the commas and convert it back into an array. And then the loop just spits them out one at a time. I got Kevin up there because I didn't do a right line. There you go. So what is this good for? Somebody says, I want you to pull out a bunch of data from a database and I want you to convert it into a comma-separated file. Or I want you to take an XML document and convert it into a CSV. Or a tab-separated or pipe-delimited. So you can read the contents of the XML, parse it, put it into an array, call string.join, put a pipe in there, and you automatically get rows of pipe-delimited data. Inversely, you need to take it and load it into a database. You do a split on the line of text you read from the file, converts it into an array, and then you just iterate over that, loading it into your database. one field at a time. You can also do the join with multiple characters. So maybe you'd rather have text in quotes. CSVs are good for that. Helps you deal with any commas that might be embedded in the text. The only thing you have to run into and worry about is the beginning and end of the string. The commas don't come along for the ride, or I'm sorry, the quotes don't come along for the ride because they're part of the separator. So you just do it that way. Everything's in quotes. All done. All right, any questions about arrays or strings up to this point? Okay. Talk a little past 7, so we'll go ahead and do 15 minutes, 10, 15 minutes, depending on when everybody gets back, and we'll finish up with dates and talking about exception handling. All right?